So compounds are formed by bonds. Okay, we just separated mixtures. We know that a mixture is made up of compounds or elements, and what makes up a compound is bonds. Okay, so far we talked about ionic bonds in the last unit. Now we're going to be talking about metallic and covalent and comparing that to ionic. So now, why do bonds form? Because bonds form to fulfill the octet rule. OCT, that prefix always means 8, which makes sense because atoms tend to gain, lose, or share electrons to have 8 electrons in their valence shell. Up to this point, we've only talked about gaining and losing. Now we're going to talk about sharing electrons. The 2 exceptions to this rule are hydrogen and helium, who only require 2 valence electrons. So there are 3 types of bonds. The first type is metallic bonding, and we'll come back to metallic bonding later on in this unit. But metallic bonding is just between metals. That's why it's called metallic, metal to metal bonding. Ionic bonding is what we discussed in the last unit. Ionic bonding is between metals and nonmetals. They have a difference of electronegativity greater than 1.7. Because of this really great difference in electronegativity, remember electronegativity is the ability to attract or steal an electron. The one that is highly electronegative, the one that's very able to steal an electron, is much stronger attractive force on the electrons, and it steals the electrons from the metal. That way, the nonmetal now has 8 electrons in its valence shell, and the metal lost its valence shell, so now its previous shell, which was full, is its valence shell. So this is how they still satisfy that octet rule. They lose and steal electrons in order for them each to have full outer shells. The addition or loss of electrons creates cations and anions that are held together by that positive and negative attraction. The new type of bonding that we're going to be focusing on for most of this unit is covalent bonds. So if you see that co at the beginning, co always means something like cooperation, a co-op. Co always means to work together. And that makes sense because a covalent bond is a sharing of electrons. This forms between nonmetals only. So all nonmetals, all of those elements in the upper right-hand corner of the periodic table, have high electronegativity. Therefore, the difference is going to be less than 1.7 between them. Nonmetals cannot steal electrons from another nonmetal. None of them are strong enough to actually steal an electron. So instead, the electrons are attracted to both nonmetals, and therefore they're shared between the atoms. And that's what fills the outer octet. So instead of one element just taking it and putting it on its outer shell, now the 2 outer shells overlap. So that way they both share valence electrons. The way I want you to think about covalent bonding is I want you to think of tug of war. Okay, so in tug of war, we have 2 people, one on each end, and we have a tie right in the middle. You win tug of war when the tie crosses your side. Okay, the tug of war keeps going as long as the tie is in between you. So think of the tie as being the electron. As long as the electron is between the 2 of these, this is a covalent compound. They're sharing those electrons because they are both very electronegative. They're both pulling on those electrons. Neither one of them is strong enough to fully pull off the electron from the other guy. Neither one of them is strong enough to win the tug of war. That's what a covalent bond is. Now we have a difference here on if they are an evenly matched or an unevenly matched. So if it's nonpolar, think of poles like the North and South Pole having 2 extremes. Okay, if you're nonpolar, you don't have 2 extremes, then the nonmetals have the same electronegativity, and the electrons are equally shared. So if it's nonpolar, it's an even tug of war, and that flag stays straight in the middle. They're both just as strong as each other. They both have the same electronegativity, which is the measure of their strength. So all 7 of the diatomics are nonpolar. Because one oxygen is not going to be more electronegative than another oxygen. All oxygens have the same electronegativity. So these can both evenly pull on these electrons between them. So since they both evenly pull, the electrons stay right in the middle, and the overall, there is no positive and negative end. Based off of this drawing, you should be able to draw the chlorine model here. You'll come back and do that for your homework. You only have like 3 problems for homework. Now the polar covalent bond is if the nonmetals have a difference in electronegativity. If they have a difference in electronegativity, the electrons are still shared. Neither one of them is strong enough to win the tug of war, but they're shared unequally. One of them is able to pull that flag closer to itself at all times. What this means is they are unevenly matched, but still willing to share, or the fight still goes on. The uneven sharing of electrons creates a slightly positive charged and a slightly negative charged end. If one of them is holding on to the electrons more, it's going to be slightly negative. It's pulling in more electrons to itself. If one of them is less able to hold on to the electrons, then it's slightly positive. It has slightly fewer electrons than it should. Okay, so if we have a slightly positive and a slightly negative end, then we have poles. If it's polar, we have a positive and a negative end. So these are called polar because they have a positive and negative pole. Think like the North and the South Pole. Water is a polar covalent bond. The fact that water is a polar covalent bond is one of the bases for why we're capable of living on Earth. Water is crucial not because you have to drink it, but also the way that water interacts with other things. Water is able to dissolve almost everything. That's what we call it the universal solvent because it's polar. This positive and this negative end are able to pull apart other things that you put inside water. That's why it dissolves things. So this polar part of water is very crucial. We're going to be using this information throughout. So why is water polar? Well, oxygen's electronegativity is 3.4. Hydrogen's is 2.2. So the difference in these is 1.2. It's still less than 1.7, so neither one of them is capable of actually stealing the electron. But oxygen is able to attract the electrons to itself more often. And therefore, he ends up with a slightly negative charge. He's kind of being selfish. He's holding on to these electrons a little bit more than the hydrogen is, so he has a little bit more electrons than he even should have, which makes him slightly negative. The hydrogens are only slightly attract the electrons, and therefore have a slightly positive charge. If oxygen's hogging most of the electrons, then hydrogen ends up being slightly positive. And we're not talking about fully negative and fully positive. Like ions, it's +1 or +2, -1, -2. This is more like a -0.1 part and a -0.2 or a +0.2. So it's just slightly positive and negative, but it's enough to create effects on other things. So I want you to come back and answer these 2 questions, and that's it for today's notes.